Section 6.5 covers applications of rational expressions. So one thing we can do is solve a rational expression for a specific value. So it's really common for formulas to contain multiple variables as well as rational expressions. We can solve for any given variable, but the first thing we have to do is multiply by the least common denominator. Now I want to solve 1 over f equals 1 over p plus 1 over q for p. So I need to figure out the LCD of this function. Well, the LCD of this function is going to be fpq. Because the LCD of f, p, and q is all of them multiplied together, right? fpq. So I'm going to multiply both sides of this equation by fpq. That gives me fpq over f equals 1 over, fpq over p plus fpq over q. So my f's are going to cancel, my p's are going to cancel, and my q's are going to cancel. This leaves me with pq equals fq plus fp. And I want to solve this function for p. So the first thing I'm going to do is get both my p's on the same side of the equation. So I'm going to subtract fp from both sides. pq minus fp equals fq. I can then pull out a factor of p on this left-hand side. So I get p times q minus f equals fq. I can then multiply both sides by q minus f in order to isolate p, because p is the variable we're trying to solve for. So I'm left with p equals fq over q minus f. Next, let's look at equation 2. I'm going to solve I equals ne over r plus nr for n. Well, the first thing we need to do is determine the least common denominator. So let's make us some room. So the LCD of this function right here is just r plus nr, because that's our only denominator. So I have I equals ne over r plus nr, and I'm going to go ahead and multiply both sides by that denominator. I have I r plus I n r equals ne, and I need to solve this for n. So I need both terms that contain an n on one side of the equation. So I'm going to subtract I and r from both sides. I get that IR equals NE minus INR, and then I'm going to pull out a factor of n. So I get IR equals n times E minus IR, and I can divide both sides by E minus IR in order to get my n all by itself. So I have I capital R equals E minus IR is equal to n. So I've solved my rational function for a specific variable. Another application of rational expressions is proportions. So friendly reminder that a ratio, that can also be called a fraction or a quotient, right? Those are all synonyms, is a comparison of two quantities. The ratio of A to B can be written as A to B, A colon B, or most commonly A over B. A proportion is a statement that two ratios are equal. So for example, I have that 1/2 equals 2/4. But I can also solve these for a given variable. Let's take a look at an example. A proportion can be solved by cross multiplying. In order to solve this, I would cross multiply A times D and C times B. So let's take a look at example 1. I have x over 4 equals 3 over 2. If I cross multiply, I get 3 times 4, which is 12, equals 2x, and I divide both sides by 2, I get x equals 6. You can see that if I'm to substitute 6 back in, 6/4 is indeed equivalent to 3/2. Let's try this again with example 2. If I have 1 over 5x equals 3/10, I'm going to go ahead and take 1 times 10, which is 10, and 3 times 5x, which is 15x. If I divide both sides by 15, I get x equals 2/3. So that's going to be the value I'd have to plug in for x in order to make these two proportions equivalent. They're also really helpful in solving word problems. So for example, in 2016, about 9 out of every 100 Americans had no health insurance. The population at that time was 323 million. How many millions of Americans had no health insurance? So my first ratio that I have is 9 out of every 100 Americans. So this is the people who did not have insurance. That's my numerator. And my denominator is just Americans. Well, there weren't just 100 Americans in 2016. There were 323 million. And I want to know how many then out of the entire population wouldn't have insurance. So I can do this by cross multiplying. I'm going to take 100 times x, and that gives me 100x. I'm going to take 9 times 323 million. That gives me 2,907 million. Then I can go ahead and divide both sides by 100. So I get x equals 290.7. Nope. I gotta move that decimal place over more. So I'm dividing by 100. I get 29.07 million Americans had no health insurance. Let's do another example. Miss Miller's car uses 10 gallons of gas to drive 210 miles. She has 5 gallons of gas left and wants to know how much more gas she will need to drive 640 miles. If the car continues at the same rate, how many more gallons of gas will she need? So let's set up our first proportion. I know that I can go 10 miles. If I have 10 gallons, I can go 210 miles. I'm trying to drive 640 miles. So let's make sure both of our miles are in the denominator together. I have 5 gallons of gas left, but I need to know how much more I'm going to need. So that's going to be 5 plus x. I'm going to go ahead and cross multiply. 10 times 640 is 6,400. 210 times 5 plus x, that gives me 1,050 plus 210x, and those are equal. I'm going to subtract 1,050 from both sides. So I get 210x equals 5,350. Now I'm going to have to divide that by 210. And I get that I need about 25.48 gallons. I have had a couple of you guys ask me about rounding. In the homework, it'll tell you whether or not it wants you to round to the tenths place or the hundredths place. In my class, I never want more than 3 decimal places. Also, think about the application. I'm trying to pump gas. I'm assuming most of us have pumped gas before. It doesn't give you more than like tenths and thousandths of a gallon, right? It doesn't go to like 4 or 5 decimal places. So also think about your application.